In this lab, we are going to look into the concepts of delta modulation. Delta modulation is a differential pulse code modulation technique in which the different signal is encoded into a single bit. Here, it provides the staircase approximation of the input sampled signal, where 1 bit per sample is transmitted. This 1 bit is sent by comparing the present sample value with the previous sample value, and the result whether the amplitude is to be increased or decreased. If the step is increased, 1 is to be transmitted, and if the step is decreased, 0 is to be transmitted. In this circuit diagram, we have 4 parts. The one is comparator, voltage regulator, product modulator, and integrator. Here we are going to see the function of the comparator. So this is the non-inverting comparator. The message signal, that is the modulating signal m of t, is given as an input to the non-inverting terminal, and the reconstructed version of this signal is given as an input to the inverting terminal. So this comparator compare these two signals and generates the difference between these two. The difference will be either positive or negative polarity. So the step size increases or decreases based on this polarity. So here we can observe the output of the comparator at this point. So this output of the comparator is regulated by using the Zener Diode. This is the voltage regulator. So the next is the product modulator. So the product modulator, here we are using the AND gate, that is 7408 IC. So it consists of two inputs. One is the pulse signal, which is generated by using the function generator, and the other one is the regulated comparator output. By multiplying these two signals, we will be observing the delta modulated signal at this point. This delta modulated signal is given as an input to the integrator. Here the integrator output is given to the, this is the first stage of the reconstructed version of the signal, and this is given as an input to the inverting terminal of the comparator. And also at this point we will be observing the slope overload distortion by adjusting the or by varying the amplitude of the modulating signal. So this is the operation of this delta modulated circuit. This is the demodulated circuit. Here the delta modulated signal is given as an input to the demodulated circuit. So here we are using two stages of low pass filter. This one is the first stage. This is the second stage. At this stage we will be observing the first stage reconstructed version of the signal. At the second stage we will be observing the second stage reconstructed version of the signal with reduced ripples. So as I told you that we have 4 parts in delta modulator circuit. This one is the comparator, this is voltage regulator, product modulator, and this is the integrator. Okay, so from the integrator we are giving the output of the integrator is giving as input to the inverting terminal of the comparator. So we have to give two inputs to the comparator. So one is the message signal, which is given to the non-inverting terminal of the comparator, and another one is the integrator output, that is the reconstructed version of the signal, which is given as an input to the inverting terminal of the comparator. So this is the, so we are going to observe the input signal and the reconstructed signal. So this is the input signal, that is a message signal. This is the reconstructed first version. These two signals are given as an input to the comparator. So now we are going to check the output at each stage. First we are going to check the output at the comparator. So this is the comparator output. And this one is the regulated output, that is voltage regulator output. Now we are going to check the output at the product modulator. So product modulator, we are giving two inputs. So one is the regulated voltage and another one is the pulse signal. So we are checking the output, that is the delta modulated signal at the third pin. So we can observe this in the CRO. So this is the pulse signal. This one is the delta modulated signal. So next we are going to check the output at the integrated point. So for that we have to give the delta modulated signal is given as an input to the integrator, and at the output point, that is the here the integrator, this point we are going to check the slope overload condition. So this is the integrated output. So you can see only the half of this cycle is approximated by the step signal, right? So you can compare this with this input signal. So only half of the signal is approximated by the step. So this condition is called after slope overload condition. So now we are going to observe the before slope overload condition. See in this is the before slope overload condition. Here you can see the both sides of the signals are approximated by the step. For both slope overload condition, you have to note down the amplitude of the message signal. Next, we are going to observe the step size of the signal at the integrator output. For that, we have to vary the amplitude of the message signal. That is, we have to reduce the amplitude of the message signal, and we can observe the output at the integrator. So this is the demodulator circuit. So in this circuit, the delta modulated signal, so this is the delta modulated signal which is given as an input to the demodulated circuit. So here you can observe the first reconstructed version of the signal, and here this is the second stage. At this point you can observe the second stage of reconstructed signal. So at this stage the ripples can be reduced. So you will be observing that signal in the CRO. So this is the first stage and this is the second stage. You can see that in the second stage the ripples reduced.